right now, humanity is acting like a terrible detective. We build giant telescopes hoping to catch a radio signal from another galaxy. We spend billions looking for intelligent life thousands of light years away. We're staring at the horizon through binoculars, while the alien is already sitting in a test tube right under our microscope. Right now, while you're watching this video, there is evidence sitting in NASA archives and labs all over the world. I'm not talking about blurry UFO pics or crazy stories from farmers. I'm talking about actual biological samples. Living organisms that we found in space, brought back to Earth, held in our hands, and then, in a panic, shoved onto the farthest shelf labeled Equipment Error. We didn't just maybe find aliens. If you look at declassified reports and forgotten experiments from the 70s, contact has already happened. We just weren't ready for it. We were expecting Star Wars, but we got mold that eats radiation, and it freaked us out. Today, I'm not going to tell you a story about what might happen. I'm telling you about what already happened. About biological traces, living organisms we found in space, dragged into labs, and then decided to just forget about because it breaks our worldview. Grab some tea. This is going to get uncomfortable. 1976. Two NASA landers, Viking 1 and Viking 2, touched down on Mars. It was a triumph. First successful landings, but hardly anyone remembers why they went there. Not just to snap pics of red rocks. They had a mission: find life. On board, there was an experiment designed by Dr. Gilbert Levin. It was called Labeled Release. The idea was genius in its simplicity. If there are microbes on Mars, they need to eat. The robot scooped up some Martian soil, put it in a container, and injected a nutrient soup, a solution with radioactive carbon-14. The logic. If there's something alive in that dirt, it'll eat the soup, digest it, and exhale gas. Radioactive gas. The detector would pick that up. Levin was sitting at JPL, waiting. The data had a 20-minute delay. The first graph came in. Flatline, flatline. Bam! A sharp spike. The soil exhaled. The radiation levels jumped exactly the way they do with living bacteria on Earth. Not a little bit, but powerfully, confidently. Levin was in shock. They repeated the experiment on the other lander, 4,000 miles away. Same result. They heated the soil to 160 degrees Celsius to kill anything living. A control test. The reaction stopped. That is classic proof of biology. If you kill the sample, it stops breathing. Chemistry doesn't work like that. Chemistry doesn't care about 160 degrees. It will keep reacting. But biology died. Gilbert Levin called management. Guys, we found life. You know what NASA said? They said, no. Why? Because another instrument on the same Viking didn't find organic molecules in the soil. At all. NASA decided, you can't have life without organics. So, Levin's experiment is a mistake. It's probably just some weird hydrogen peroxide chemistry. Official verdict. Life not found until his death in 2021. Levin was shouting, writing papers, begging them to review the data. He said, we met Martians, and then we ignored them. And here's a cliffhanger that'll give you goosebumps. In 2018, 40 years later, Curiosity rover found organics on Mars. The exact thing Viking was missing. Turns out, Viking's gear just wasn't sensitive enough. Or it burned the organics during analysis. The main argument against Levin's discovery collapsed. But did we rewrite the textbooks? Did we announce contact? No. Silence. We found the keys, but decided it was just trash that looked like keys. Listen, let's be real. What's our main problem? We're waiting for Star Trek. We're expecting a ship to land, a guy with a ridged forehead to walk out and say, "Take me to your leader." We're looking for intelligence. We're looking for tech. But the universe doesn't work like that. Look at Earth's history. Our planet has been around for 4.5 billion years. You know how long humans capable of sending a radio signal have been here? About 100 years. That's a blink, a spark. And how long was it just slime? Bacteria? Single-celled stuff. Almost 4 billion years. If you poke a finger at any random point in time, and space where there's life, 99.999% of the time you're going to hit mold, a microbe, a fungus, not Einstein. And here's where it gets interesting. We've already found things that act like life, look like life, but we're too scared to call them aliens, because it doesn't fit the Hollywood script. Aliens aren't necessarily humanoids. It could be moss on an asteroid. It could be a bacterium in the clouds of Venus. And the scariest part, they might already be here in Earth's orbit. Have you heard about the sea plankton on the ISS? Well, that's an official Roscosmos report. August 2014. Russian cosmonauts Alexander Skvortsov and Oleg Artemyev go on a spacewalk. Routine job, clean the windows. They take special swabs and wipe the outside surface of the station. The part in the vacuum. The part roasting in radiation and freezing in the cold. They bag the swabs, send them to Earth. Scientists at the Institute open the tubes, look under the microscope and their jaws hit the floor. On the swabs, DNA of marine plankton, bacteria, traces of diatoms, alive. Vladimir Solovyov, flight director for the Russian segment of the ISS, officially confirmed this. Where the hell did marine plankton come from on the hull of a space station flying at 400 kilometers up? Skeptics say, oh, we brought it from Earth. Contamination? But wait. The ISS doesn't launch from the ocean. Modules were assembled in sterile clean rooms. Baikonur is in the steppes of Kazakhstan. There's no sea plankton there. Plus, air currents from Earth don't rise to 400 kilometers. That's physically impossible. That's the edge of the ionosphere. The only explanation that doesn't break physics, but breaks your brain. Earth is constantly dusting life into space, and space is dusting onto us. It's called panspermia. The hypothesis that life doesn't just sit on planets. It travels. Imagine the ISS is your car windshield. You're driving down the highway, and bugs splat on the glass. Only the ISS is flying through deep space, and microorganisms splattered onto it. Where are they from? Earth? Or were they just floating by? If they were floating by, then they are aliens. Maybe dumb, maybe single-celled. But that is biology living in a vacuum. But the news went quiet. Where were the emergency broadcasts? The Time magazine covers. "Oh, we found bacteria," happens. Seriously, we found life in a vacuum and nobody cares. Okay, Mars is boring. The ISS is debatable. Let's go to hell. Venus. Surface temperature, melted lead. Pressure, crushing. No life can be there. But at 50 kilometers up, conditions are actually decent. It's warm, pressure is like Earth. Sure, the clouds are made of sulfuric acid, but nobody's perfect. September 2020. A group of astronomers led by Jane Greaves from Cardiff University makes a statement. They found gas in Venus's clouds. Phosphine pH 3. Why is that mind-blowing? Phosphine is a super picky molecule. On rocky planets like Earth or Venus, it doesn't just form geologically. Volcanoes don't make it in those amounts. Lightning doesn't either. On Earth, only 2 authors make phosphine. Human labs for chemical weapons or pesticides. Anaerobic bacteria microbes living without oxygen in swamps or badger guts. That's it. There are no other sources. Greaves' team checked the data again. They used telescopes in Hawaii and Chile. Phosphine is there, and there's a lot of it. It's a biomarker. If we saw that spectrum on an exoplanet 100 light years away, we'd say, there is 100% life there. But this is Venus, our neighbor. A fight started, a scientific brawl. Other scientists started yelling, calibration error. It's sulfur dioxide. You messed up. That's normal, that's science. But here's the kicker. A few years passed. The data was refined. The phosphine signal is still there. It's weaker than they first thought, but it exists. And it's coming from the clouds. Something in Venus's atmosphere is producing a gas that, as far as we know, only life produces. We are literally looking at an alien biosphere hanging in the clouds. But we're scared to say it's aliens. We say anomalous chemistry of unknown nature. Feel the difference? We're ready to invent new, non-existent chemistry just to avoid admitting the obvious. Life is the mold of the universe. It's everywhere. I saved the best for last. Because in this case we have a body. Not gas, not a graph on a screen. A physical object you can touch. Antarctica. Meteorite hunters find a weird green rock weighing about 2 kilos. They named it ALH84001. Analysis showed it's a piece of Mars. Yes, we can determine that by the gas trapped inside the rock. It matches Mars's atmosphere. Millions of years ago, something huge hit Mars, knocked this chunk into space. It floated there for an eternity, and 13,000 years ago, it fell in Antarctica. In 1996, NASA scientist David McKay and his team sawed it open, and they looked under an electron microscope. What they saw made US President Bill Clinton give an emergency address to the nation. Do you often see a president give a speech because of a rock? Inside the meteorite, they found microscopic structures. They look exactly like fossilized bacteria. Little worms, segmented, just like our Earth bacteria, but way smaller. And next to them, magnetite crystals. Listen closely. Magnetite crystals of this perfect shape are only created on Earth by specific bacteria that use them as a compass. Non-living nature makes magnetite, sure, but it's crooked, chaotic. These are the fingerprints of life. The paper was published in Science. It was a bombshell. We found fossilized Martians. But what happened next? Skeptics piled on. They're too small for DNA. Nanobacteria. It's a microscope artifact. It's Earth contamination. Even though they were inside the rock. Almost 30 years have passed. The debate isn't over, but new studies show explaining the origin of those crystals without biology is practically impossible. You have to invent such complex, unbelievable volcanic scenarios that we've never even seen. But we're silent again. The meteorite sits in storage. We keep looking for life, ignoring the fact that we already have an alien corpse, just a very small one. Why does this happen? Why, every time we find evidence, Viking, ISS, Venus, meteorites, do we go into denial mode? Because we're looking for another us. We're egocentric. We need a conversation partner. We need someone who built pyramids or sent a warp drive blueprint. We don't want to admit that we're just a random spark of mind in an ocean of slime. But the reality is likely this: space is teeming with life. Asteroids carry spores of bacteria and tardigrades, which, by the way, survive in deep space for years. Planets swap biological material after meteor impacts. Life isn't a miracle. It's a chemical inevitability. Where there's water and energy, something's going to start wriggling. We've already found aliens. They are microscopic. They live in sulfur. They eat radiation. They sleep inside rocks for millions of years. They don't build cities. They don't care about us. And that's what scares us the most. We're not afraid of an invasion. We're afraid of disappointment. We are standing on the brink of the greatest realization in history. Right now, the JUICE probe is flying to Jupiter's moons. Clipper is flying to Europa. Dragonfly is getting ready for Titan. We're going to the oceans under the ice. But I want you to look at the sky differently after this video. Don't look for sources. Imagine that the space between stars isn't empty. It's a river, and seeds are floating in that river. We found them on the ISS hull. We found them in Antarctic rocks. We are not alone. We just live in a very crowded dorm, but we refuse to say hi to the neighbors because they're too small. But you know what the funniest part is? If life spreads that easily, if bacteria can travel on meteorites, then maybe we are the aliens. Maybe life on Earth started when a rock crashed into a warm ocean billions of years ago. And we are just Martian, or someone else's, mold that grew up and learned how to make YouTube videos. Think about that. Thank you for watching. Please subscribe if you want to see more of our videos. See you soon.